On October 19th, 2017, a telescope named Pan-STARRS, sitting on top of a dormant volcano in Hawaii, recorded a single point of light moving across the sky in a way that no astronomer had ever documented before. The object was catalogued that same week and given a name that means scout or messenger in Hawaiian, Oumuamua. Its official designation is 1I 2017 U1. That 1I matters more than almost any other label in the history of astronomy, because the I stands for interstellar, and the 1 means it was the first. Not the first object astronomers thought might have come from beyond our solar system, not the first candidate, the first confirmed one ever in the entire written record of human observation. Before that October morning, every comet, every asteroid, every chunk of ice and rock that astronomers had ever tracked belonged to the solar system. It had always belonged here, born from the same disk of gas and dust that made the sun, the planets, and us. Oumuamua did not belong here. Its trajectory was hyperbolic, meaning it was moving too fast, on too open a curve, to ever have been gravitationally bound to the sun. It came from outside, passed through, and was already on its way back out before anyone even noticed it was here. When it was found, it was already leaving. That single fact set the tone for everything that followed. The numbers alone are strange enough to earn a place in any account of this object, so let's start with the ones that were actually measured, not guessed at. Oumuamua was moving at roughly 87,000 miles per hour relative to the sun when it was discovered, and it had already made its closest approach weeks earlier, swinging inside the orbit of Mercury before astronomers ever laid eyes on it. It was tumbling, not spinning smoothly on a single axis, but genuinely tumbling end over end in a chaotic rotation with a period of about 8 hours. Its brightness changed by a factor of about 10 as it tumbled, which is an enormous swing, and that swing was the first clue that something about its shape was deeply unusual. A roughly spherical object doesn't dim and brighten by a factor of 10 as it turns. Something elongated does. The best fit models that came out of the observational data suggested an object with an extreme aspect ratio, something like 6 times longer than it is wide, or in some estimates even more extreme than that, shaped less like a typical asteroid and more like a cigar, or in later refined models, more like a flattened pancake. Either way, nothing in our own solar system's population of asteroids and comets looks like that. It was reddish in color, similar to some outer solar system bodies, consistent with a surface that had been irradiated by cosmic rays for a very long time. And here's the detail that actually broke the models. As Oumuamua left the solar system, it sped up. Not by a huge amount, but by a measurable, statistically significant amount that could not be explained by the sun's gravity alone. Something was giving it a small extra push. That's not speculation. That acceleration is in the data. It was published, checked, and rechecked by multiple independent teams using the tracking data from telescopes around the world, because an object leaving the solar system on a hyperbolic trajectory should decelerate as it climbs out of the sun's gravity well, the same way a ball thrown upwards slows down as gravity pulls on it. Oumuamua didn't just fail to decelerate as much as expected, it accelerated in a direction consistent with something pushing it away from the sun, a non-gravitational acceleration. And this is where the real scientific argument began. An argument that, in some ways, is still not fully settled. The most natural explanation for an object speeding up as it leaves the sun is outgassing. Comets do this constantly. As a comet made of ice approaches the sun, the ice sublimates, turns directly from solid to gas, and jets out from the surface, and that jetting acts like a tiny, uneven rocket engine, nudging the comet's path in small but measurable ways. This is well understood, well documented, and has been observed in hundreds of comets. The problem is that when astronomers turned their telescopes on Oumuamua looking for the telltale signs of outgassing, they found nothing. No coma, no tail, no cloud of dust and gas surrounding the object the way you'd expect from an active, sublimating body. The Webb Space Telescope specifically searched for carbon dioxide and other gas emissions and came up empty, with upper limits so low that they ruled out the most common outgassing explanations. This left researchers with a genuine puzzle. An object that accelerated like a comet, but showed none of the visual signatures of a comet. Several groups worked to patch this hole with more exotic, but still entirely natural explanations. One prominent hypothesis suggested that Oumuamua might be made largely of solid hydrogen ice, a material that would sublimate without producing the kind of dust or visible coma that normal water ice comets produce, essentially a comet that outgasses invisibly. Another team proposed that the object might be composed significantly of solid nitrogen ice, similar in composition to the surface of Pluto, and that a chunk of this material, chipped off the surface of a Pluto-like planet in another solar system by some ancient collision, could explain both the shape, flattened and pancake-like under this model, and the acceleration, again through sublimation, that wouldn't produce a visible plume the way water ice would. These hypotheses are worth taking seriously because they stay entirely within known physics and known planetary formation processes. They don't require anything exotic beyond finding the right, slightly unusual, but still natural material. And then there was the third explanation, the one that made headlines around the world and is probably the reason you're listening to this in the first place. Avi Loeb, who at the time chaired the astronomy department at Harvard, argued that the observed acceleration, combined with the extreme shape, the lack of any visible outgassing, and the object's unusual thin, high aspect ratio geometry, was at minimum consistent with an artificial origin. Specifically, he proposed that Oumuamua could be, or could have started life as, a light sail, a thin, artificial structure designed to be pushed by the pressure of sunlight itself, the same basic principle that some human engineers have proposed for interstellar probes of our own. A light sail with a very low mass relative to its surface area would feel a meaningful push from sunlight, and that push could produce exactly the kind of extra acceleration that was measured without needing any gas or dust to be detected at all, because there wouldn't be any. No outgassing, no coma, just physics acting directly on a thin, reflective structure. It's important to be precise about what this hypothesis actually claimed and what it didn't. Loeb never claimed certainty. He explicitly framed the light sail idea as one hypothesis among several that fit the data, and he argued that scientific rigor demanded taking it seriously rather than dismissing it purely because it was uncomfortable or extraordinary. That argument, more than the hypothesis itself, is what set off a firestorm within the astronomical community. Many astronomers pushed back hard, not necessarily because they had a fully satisfying alternative explanation nailed down, but because they felt that jumping to an artificial explanation before exhausting natural ones set a bad precedent for how science should be done. The nitrogen ice hypothesis and the hydrogen iceberg hypothesis were both published specifically as responses trying to demonstrate that natural explanations remained viable. The debate was genuinely heated, genuinely public, and genuinely unresolved by the time Oumuamua slipped out of range of even our most powerful telescopes. And that's the other maddening piece of this story. We ran out of time. Oumuamua was only detectable for about 80 days after its discovery before it became too faint, too distant, for existing telescopes to gather any more useful data. It was moving fast. It was small. Current estimates suggest somewhere in the range of a couple 100 meters across, and it was already leaving. There was no mission that could be scrambled in time to intercept it, no way to send a probe, no way to get a closer look. Every question raised by those 80 days of data, the shape, the composition, the acceleration, the total absence of any detectable coma, remains open because the object is gone. It's now somewhere beyond the orbit of Neptune, headed back out into interstellar space, and it will never return. Whatever Oumuamua actually was, natural in a strange new way or something else entirely, we may never fully know because the window to study it directly has permanently closed. Now, here's where the story most people know actually ends, and where the story I want to tell you actually gets interesting, because Oumuamua was not, in fact, a one-time event. Just under 2 years later, in August 2019, an amateur astronomer named Gennady Borisov, observing from Crimea with a telescope he built himself, spotted a second object on a hyperbolic trajectory. It was designated 2I Borisov, the second confirmed interstellar object. Unlike Oumuamua, the 2I Borisov behaved exactly like the comets we already know well. It had a visible coma, a genuine tail, active outgassing of water ice, and a composition that, while interstellar in origin, looked broadly consistent with the comets we've studied in our own solar system for centuries. In a way, 2I Borisov was reassuring. It confirmed that interstellar objects are real, that they do pass through our solar system, and that at least some of them are exactly what you'd expect. Ordinary cometary material, ejected from some other star system by gravitational interactions with planets, wandering the galaxy for millions or billions of years until, by pure chance, one of them drifts close enough to our sun for us to notice. But 2I Borisov also did something else. It changed the math. Two objects, found within 2 years of each other, using survey telescopes that were nowhere near sensitive enough to catch every interstellar visitor passing through, told astronomers something important. These objects are not vanishingly rare freak occurrences. If our limited patchy sky surveys managed to catch 2 of them by essentially blind luck within 24 months, then the actual population of interstellar objects passing through the solar system at any given time must be enormous, vastly larger than anyone had assumed before 2017. Researchers began publishing population estimates, suggesting that interstellar objects of Oumuamua's size or larger might be passing through the inner solar system constantly, potentially multiple times per year, simply too faint, too fast, or too poorly timed relative to our current telescope coverage for us to catch them. We weren't looking at two rare guests. We were looking at the tip of a very large, very old, and very continuous stream of material drifting between the stars, most of which had simply been passing by, undetected, for the entire history of astronomy, right up until our instruments finally became good enough to catch a couple of them in the act. Which brings us to the third one. And this is the part of the story that is genuinely current, genuinely recent, and genuinely underreported relative to how significant it actually is. On July 1st, 2025, the Atlas Survey Telescope, based in Chile and originally built as part of NASA's Planetary Defense Network to watch for asteroids that might threaten Earth, picked up a faint 20th magnitude point of light that didn't behave like anything in our solar system should. It was given a temporary designation, then confirmed and renamed 3I Atlas, the third confirmed interstellar object in human history, and unlike Oumuamua, which was already leaving by the time we spotted it, 3I Atlas was caught early, while it was still inbound, still between the orbits of Mars and Jupiter, still months away from its closest approach to the Sun. For the first time, astronomers had a real head start. What they found, once dozens of telescopes and instruments around the world and in space turned toward it, was remarkable. Estimates of its nucleus, refined using Hubble Space Telescope observations in August 2025, put its diameter somewhere between roughly 440 meters and as much as 6 kilometers across, some analyses leaning toward the larger end of that range, which would make it substantially bigger than either Oumuamua or 2I Borisov, potentially one of the largest interstellar objects ever detected. Its velocity was staggering even by the standards of the previous two. About 137,000 miles per hour when discovered, climbing to roughly 153,000 miles per hour at its closest approach to the Sun in late October 2025. Its trajectory, when traced backward, suggested it may have been drifting through interstellar space, potentially through the galaxy's thick disk, a region populated largely by older stars, for hundreds of millions of years, possibly longer, before its chance encounter with our solar system. Unlike Oumuamua, 3I Atlas showed clear, unambiguous signs of cometary activity almost immediately. Deep stacked images from the European Southern Observatory's Very Large Telescope and the Canada-France-Hawaii Telescope resolved a genuine coma, the diffuse cloud of gas and dust that surrounds an active sublimating comet. Its color and spectral properties matched what astronomers would expect from a primitive, ancient body, similar in many respects to comets and certain classes of asteroids native to our own solar system. In other words, on the surface, 3I Atlas looked far more like 2I Borisov than like Oumuamua, a real, active, honest-to-goodness comet that simply happened to originate around a different star. But here's where the not alone part of this story earns its place, and it has nothing to do with aliens riding along inside a comet. Because 3I Atlas reignited almost instantly the exact same question Oumuamua had raised 8 years earlier. And this time, the scientific community had a plan ready to go. The Breakthrough Listen Initiative, the largest scientific program in history dedicated to searching for technosignatures, evidence of technology, not necessarily life itself, but technology coming from beyond Earth, turned its instruments directly at 3I Atlas almost as soon as it was discovered. This wasn't a fringe effort. It used the Allen Telescope Array within days of the object's discovery in July 2025. And then, as 3I Atlas made its closest approach to Earth on December 19th, 2025, at a distance of about 7 astronomical units, roughly 167 million miles. Breakthrough Listen used the largest steerable single-dish radio telescope on the planet, the 100-meter Green Bank telescope, to listen across a huge swath of the radio spectrum, sensitive enough at that distance to detect a transmitter with a power output of roughly 1/10 of a watt. That is an extraordinary level of sensitivity. If there had been anything even remotely resembling an artificial radio transmission coming from that object, this search had a real chance of catching it. It found nothing. No artificial radio emission localized to 3I Atlas was detected at any point across any of these observations. The official position from NASA, the European Space Agency, and the overwhelming majority of astronomers who have studied 3I Atlas remains exactly what the data supports. It is a natural comet, the third confirmed interstellar object, and there is no evidence that it is anything other than an ordinary, if ancient and well-traveled, chunk of primordial material from another star system. That needs to be said clearly and without hedging, because it's true, and because responsible storytelling about extraordinary topics means giving you the actual conclusion the scientists reached, not just the tantalizing question they started with. But notice what actually happened here, because it's the real headline hiding underneath all of this, and it's a headline made entirely of real, documented, verifiable events rather than speculation. In the space of 8 years, humanity went from having 0 confirmed interstellar objects to one deeply strange one we couldn't fully explain and never got a second look at, to a second, more ordinary one that behaved like a textbook comet, to a third one, larger than the first two, caught early enough that we could throw our best instruments at it in real time, including a dedicated, sensitive professional search for artificial signals. 3 objects, confirmed, catalogued, studied by name, in under a decade. And every single serious researcher in this field will tell you the same thing. 3 is not the ceiling. 3 is simply the number our current, still relatively limited survey telescopes have managed to catch so far almost entirely by chance, using instruments that were built for other purposes, planetary defense, general sky surveys, and stumbled onto these objects as a byproduct. That matters enormously for what comes next, because right now, as this is being recorded, the astronomical community is on the verge of switching on an instrument specifically built to solve this exact blind spot. The Vera C. Rubin Observatory, perched in the Chilean Andes, is designed to conduct the most comprehensive, most sensitive, most rapid repeated survey of the entire visible sky ever attempted, cataloging the sky over and over again every few nights for a decade, specifically built to catch fast-moving faint objects that slip through the gaps of older, narrower surveys. Multiple research teams, independently using different statistical models based on the detection rates of Oumuamua, 2I Borisov, and 3I Atlas, have projected that once Rubin is running at full capacity, it could detect somewhere between several and several dozen new interstellar objects every single year. Not per decade, per year. If those projections hold, the entire premise of this story, the framing that interstellar visitors are rare, exotic, one-off events worth global headlines, is about to become obsolete within just a few years. We are not looking at a universe with a handful of interstellar wanderers. We're looking at a galaxy where interstellar material is constantly, continuously drifting through our solar system all the time, in numbers we are only now developing the technology to actually count. So let's go back to that word in the title, alone, because I think it deserves a more precise answer than a vague sense of cosmic dread. Oumuamua is not alone in the sense that it was never a unique event to begin with. It was simply the first one we happened to catch. The leading edge of what population statistics now tell us must be a constant, ongoing traffic of interstellar debris flowing through our solar system, most of it too small, too dim, or too poorly timed relative to our sky coverage for us to notice. Every single one of these objects, whether it behaves like an ordinary comet, the way 2I Borisov and 3I Atlas did, or like the genuinely strange outlier that Oumuamua turned out to be, is a physical sample of material formed around a different star, flung out into the galaxy by some ancient gravitational encounter, and drifting for millions or hundreds of millions of years before by sheer chance, brushing past our own small corner of the Milky Way. That is not a small thing. That is, on its own, one of the most remarkable developments in the entire history of observational astronomy, and it happened almost entirely within the last decade, largely within your own lifetime if you're listening to this now. Now, let's address the other half of that title directly and honestly, because I promised you this would be grounded in what actually happened rather than manufactured drama. And Oumuamua's story does not include it literally reversing course and heading back toward us. It didn't turn around. It came in on a hyperbolic trajectory, swung around the sun and left, exactly as the physics of an unbound orbit predicts, and it is currently continuing to move away from our solar system, permanently, never to return. What actually happened, the real event buried underneath the dramatic framing, is that its outbound trajectory did not match a simple, gravity-only prediction. It accelerated when the math said it should have been decelerating. That unexpected deviation, however small in absolute terms, was large enough and precise enough to force some of the best minds in astronomy to spend years arguing about what could possibly explain it. In the language of orbital mechanics, that is an object whose path defied a clean, simple prediction. An object that, in a sense, refused to follow the script we expected it to follow. It's not the same as literally turning around, but it is genuinely one of the strangest, most scientifically significant anomalies recorded about any object ever observed passing through our solar system, and it remains to this day without a single explanation that every scientist in the field agrees on. That ambiguity is not manufactured hype. It's the real, published, peer-reviewed state of the science. What makes this whole story worth telling, worth sitting with for more than the length of a headline, is how rare it is to have a genuine, ongoing scientific mystery of this scale, one grounded entirely in real telescope data, real published research, real institutions like NASA, the European Southern Observatory, Breakthrough Listen, and dozens of university research teams around the world, all independently converging on the same set of open questions. Nobody involved in the serious study of these objects is claiming certainty about extraterrestrial technology. What they are saying consistently across multiple peer-reviewed papers and public statements is that the data from Oumuamua specifically does not yet have a fully satisfying, universally accepted natural explanation, and that the responsible scientific approach is to keep every reasonable hypothesis on the table, gather more data on future objects, and let the evidence, not the excitement, drive the conclusion. That is exactly what happened with 2I Borisov, which turned out to be a straightforward, if origin-shifted, comet. It's exactly what has happened so far with 3I Atlas, which, despite an active, dedicated, highly sensitive search for artificial signals, has produced no evidence of anything beyond natural cometary behavior. But the story doesn't end with reassurance either, because the population statistics are the part of this that should actually keep you thinking long after this video ends. If 3 objects have been confirmed in 8 years using survey instruments that were, for the most part, not even designed for this specific purpose, and if the honest mathematical extrapolation from that detection rate suggests dozens of these objects could be identified annually once purpose-built instruments like the Vera Rubin Observatory reach full operational capacity, then we are standing at the very beginning of an entirely new field of observational astronomy. Interstellar object science, as a discipline, is barely old enough to have its own name, and yet it has already produced one object so strange that a Harvard astronomy department chair was willing to publicly argue for the possibility of an artificial origin, and a second dedicated, professional, well-funded search for alien technology aimed directly at a third object, as recently as the final weeks of 2025. Think about the timeline for a second, because laid out plainly, it's genuinely startling. 2017, the first confirmed interstellar object in human history is discovered, already leaving, and turns out to behave in ways that still cannot be fully explained by natural processes alone. Years later, 2019, a second interstellar object is discovered. This one behaving exactly as a comet should, confirming that these visitors are real and recurring rather than a one-off fluke. 2025. A third interstellar object, larger than the first 2, is discovered early enough to study in real time, prompting the most sophisticated search for artificial signals ever aimed at an interstellar visitor, using some of the most sensitive radio instruments ever built, at the closest possible distance with no detection of anything artificial. 3 objects, 3 genuinely different stories. 3 pieces of physical evidence sitting in published scientific literature right now that our solar system is not the sealed, isolated system we once assumed it to be, but a place that other star systems' debris regularly, if rarely, drifts directly through. So where does that actually leave us? It leaves us with a universe that is measurably, provably more porous than we thought it was even 10 years ago. It leaves us with a genuine, unresolved, published scientific anomaly in the behavior of the very first interstellar object we ever detected, an anomaly that multiple competing hypotheses, from exotic ice compositions to, at the far and most speculative edge, artificial origin, have tried and so far failed to fully resolve to universal satisfaction. It leaves us with a second object that behaved exactly as expected, grounding the first one's strangeness in useful context, rather than letting it float entirely alone as an inexplicable outlier. And it leaves us with a third object, the most recently studied, the most thoroughly observed, the one subjected to the most rigorous search for artificial signals ever conducted on an interstellar visitor, which came back with a clean, if slightly anticlimactic, answer: nothing artificial detected, behavior consistent with a natural comet. And yet, even with that clean answer on object number 3, the deeper implication of having 3 confirmed objects instead of 1 remains just as significant, arguably more significant, than any single anomaly could be on its own. Because it means Oumuamua's strangeness can no longer be dismissed as measurement error or a one-time fluke in a database with a sample size of exactly 1. It means we now have a baseline, a comparison set, a way to say with confidence that most interstellar objects look like 2I Borisov and 3I Atlas, ordinary, if ancient, cometary material, while at least one object out of the first 3 we've ever found looked meaningfully different enough that its own discoverers still can't fully agree on what it actually was. In a field this young, with a sample size still this small, that is not a minor detail to file away and forget. That is the entire scientific ballgame. That is the reason serious researchers are still publishing papers about a 50-meter wide object that passed within our reach for less than 3 months back in 2017 and has been gone for years. The next time you look up at a clear night sky, it's worth remembering that somewhere out there, right now, moving through the solar system at speeds that make our fastest spacecraft look stationary, there are almost certainly more objects just like these, 3, unlit, unnoticed, too faint for any current telescope to catch, drifting through on trajectories that will carry them past us and back out into the galaxy before we ever know they were here. We caught Oumuamua by chance. We caught 2I Borisov by chance, spotted by a dedicated amateur astronomer using equipment he built himself. We caught 3i Atlas through a network originally designed to protect Earth from asteroid impacts, not to hunt for interstellar visitors at all. None of these discoveries came from a purpose-built interstellar object detector, because until very recently, that instrument simply didn't exist. It's coming online now. And when it does, the question this entire story has been building toward, whether Oumuamua's strangeness was a genuine one-off anomaly or simply the first documented example of a category of object we don't yet understand, may finally get the sample size it needs to actually be answered. Until then, what we have is exactly what real, honest science looks like in progress. 1 confirmed anomaly, 2 confirmed comets, 3 confirmed visitors from beyond our sun, and a mystery that is still genuinely unresolved.